Hello and good afternoon, CTS266, Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP Switch course, and this afternoon's video tutorial is going to be a tutorial on the Cisco Learning Labs curriculum that we're integrating into the class, where we're going to be configuring Ntp. So we're looking at challenge number 10, where we're going to take all of that Ntp information we've learned so far, and we're going to implement it here in challenge 10. So as you can see, the senior engineer Dwayne has configured a Ntp design for the company, and he wants us to implement it. So we're going to need to synchronize the time of router 1 and router 2 to 5 different Ntp servers. So we can find the Ntp server information in the job aids section. We're definitely going to need to take a look at that. Other network devices should synchronize their time to R1 and R2. So if we take a look at our topology, we've got R1 and R2 here. They're going to be synchronizing to 5 Ntp time sources out here on the internet. And so then DSW1, DSW2, and my guess is Switch 2 are going to be synchronizing their time to router 1 and router 2. We want to ensure the time is going to be synchronized between devices even in the network, even if there's no connectivity to the internet. So what this screams is peering, right? So we're going to have the devices in the network peering with each other. We should also ensure that, that R1 and R2 will only be used for time synchronization by devices in our network. So that's the 192.168.0.0/16. So this is also screaming access list along with the Ntp access group command. And then they provide our time down here as Central European time, which is plus 2 hours offset. And they use summertime. So we know we're going to be setting the clock and the time zone, and we're also going to be setting up a recurring daylight savings time. And remember, that's what that summertime keyword really represents, is daylight savings time. So let's go ahead and take a look at the job aids here, and then let's dive in. So we've got all our interfaces. We're interested in those IPs right there. So 44, 111, 133, 222, and 233, those are going to be our Ntp servers. So let's start up here on router 1. So we're going to go from user exec into privilege. And now we're going to wait. I might as well pull router 2 up here while we're waiting there. And let's go from user exec to privilege exec. And let's say show run include Ntp. So no Ntp setup here on router 1. What about a show Ntp status? Ntp is not enabled. So if I say show Ntp Associations, we get nothing back. What about show clock detail? So our time source is the hardware calendar. So nothing going on here in terms of Ntp on router 2. Let's check router 1, show Ntp status. Show run include Ntp. Show Ntp Associations should show nothing. And how about show clock detail? And again, we're using the hardware clock. And ironically, if you take a look at that, that is actually pretty close. Pacific Standard Time is actually 3 hours different, so but pretty close to the actual time. Okay, so let's start out with the first task that we've got here. Let's configure router 1 and router 2. So we're going to go into global config, and again, when I'm asking or when I'm telling router 1 that I would like it to synchronize with these time servers that are out on the Ntp servers on the internet, it's just simply Ntp server followed by the IP address 209.65.1.201.44, 111, and we had 133, and then 222, I believe, 222, and then 233, 233. And the key about 233 is we want to prefer 233, which means if we make contact with all of these Ntp servers, think of the prefer as sort of like a weighting, that we are weighting it more heavily than the others, that we are trusting 233 instead of the other servers, or I should say over the other servers. However, if we were to lose access to 233, the time server that would get picked up is not the highest IP address. The time server that's going to get picked up if 233 goes down and we lose connectivity to that is going to be the time server that has the best stratum. And so let's go ahead and take a look here now, and let's see what we've got before we tweak the time zone a little bit. So let's say do show run include NTP. So we've got all of our statements in there. And then what about a do show Ntp status? So what's our status look like? So it shows the clock is synchronized. Now, just from this output here, what can you infer about the stratum on NTP server 209.165.201.233? Exactly. That the stratum on that server is 1. Because we are using that as our source, and so we say we are synchronized, and our stratum will be the NTP server stratum plus 1. So we come back with a stratum of 2. What about a do show Ntp Associations? Right? And again, this local setting that you see here, this looks like it's an IOU convention. So to talk about that real quickly, typically what you're going to see in there is you're actually going to see, and I'm going to try to pull up the, where's the pen tool at here? Where's my ink to go? There we go. So typically what you're going to see in there when you look at this output is whatever NTP server that server's referring to, you would see the IP address of that here, right? Now, since it's a stratum 1, it's not actually referring to any other server because it sees itself as a stratum 1. So our reference clocks here are going to say local. And again, the reason they all say local is because the stratum for all of them is 1. So let's go ahead real quickly here. If I were to pull up the actual Cisco hardware here, the 4 switches that we've been dealing with, and let's get on to DLS W01, show run include NTP, and let's see what we have here. So you can see we've got some information set up here. We're not set up as the master. I believe we were using router 1. Let me check real quickly down here. I think router 1 was being used, and that is way too small to see, but hang with me here. Show run include NTP, and what I may do is, so it wasn't router 1. I thought we were using router 1 as our NTP source. Maybe router 3 here? No? Let's try router 7. And show run include NTP. We weren't able to set ourselves up as a master, so it doesn't look like it was set up there. I could have swore we were using that in one of the previous labs. So typically if I say show Ntp Associations, you can see that we're pointing toward the NTP server 172.16.99.111, and the reference clock is its local clock. So we see a stratum of 9. So, and again, remember, in the associations output, let me say show Ntp status. In the associations output, the stratum value is going to be the actual stratum value of the router that's, or the NTP server that's displayed here. Remember, the show Ntp status, if we were synchronized to that time source right there, we would be stratum plus 1. So let's do this. Let's go ahead. I know that router 7 is plugged in here. Show IP interface brief. Show IP interface brief. And let's do this. So I'm going to go into global config here. Interface fast Ethernet 00. IP address 172.16.99.111. So we're going to change the IP here. And then I'm going to exit out of interface mode. And we're going to say NTP, whoops, NTP master. And we should be good. Do show NTP status. And I did not put the stratum. So NTP master, and I'll put the stratum number of 3. So do show NTP status. So there we go. So our stratum is now 3. You can see we're synchronized to our internal clock. Do show Ntp Associations, right? And for this, when on a real Cisco router, and this is running 15.3 code, you can see that we are referencing, there's that reference clock local because it's the 127.127.1.1 referring to the router itself. So again, and it looks like it bumped our stratum up. That Ntp status is stratum 3 is what we set it to. And here it looks like it dropped it down 1 on that output. So let's see what we have here. Show Ntp status. Has this guy synced up? Let's see if I can ping 172.16.99.111. All right, so I can ping it and show run, include Ntp. We should be able... Yeah, we are pointing to the right server. And you know what? I just noticed that we've got a whole bunch of authenticate information that needs to be included there. And let me see. Let's drop this down a little bit and let's paste that in there. Save our config. And hopefully we're going to see the synchronization here. Show Ntp status. So it hasn't synchronized yet. Show Ntp Association should show nothing. And we may come back to this. Actually, it looks like it picked it up there. Although we show unsynchronized, and actually I believe, because we did a stratum of 3, so we're still pointing to that same source, but it doesn't show synchronized. So we're going to come back. We'll come back to this, and hopefully it'll be synchronized there. So again, when they're referring to the local clock, right, with a stratum of 1, they are set up as the Ntp master. All right, so now we need to change the time zone, and it was Central +2, so Central European time is what they want us to do. So let's go ahead and say clock time zone. If I do a question mark, again, this is free flow, right? So I could put Central EU time, right? Put pretty much whatever I want in there. Limit, I believe, is up to 7 characters. So what is our offset? Well, we were +2. And then remember that we also had the clock was going to be for summertime CEUT. Now that needs to match because we're tying it to the time zone value we just created and recurring, right? So that means daylight savings time. It's going to auto-magically update itself, and we should be good to go. So we've got router 1 done. Let's type end, show Ntp status. We should be synchronized, stratum of 2, because again, 233 has a stratum of 1, so we're +1. Show Ntp Associations, right? There are the routers we're associated with. You can see that the plus sign is indicating these are candidates, which means we have reachability, and if 233 goes down, then one of these other servers would take over. So you can see here the asterisk means that that is the one that we are currently using as our Ntp source. So remember we said earlier, if the stratum is 1, right, or the lower stratum would be the router that would be the next Ntp candidate that would be used. Now the stratum here is all equal. So let's find out, what is it going to pick? Is it going to go with highest IP? How is it going to make that determination? And let's say no Ntp server 209.165.201.233 prefer. Do show Ntp status, right? So we're unsynchronized right now, but let's see what happens here. Do show Ntp associations. So there are the candidates. The question is, which candidate is going to end up with the asterisk next to its name? And so we'll give it some time here. So while that's sorting itself out, let's come over to router 2 and we'll knock out router 2. So we're going to go from user exec to privilege exec in a global config, and the same steps as before, right? 209.165.201.44, and then 111, 111, 131, or 133, 222.222, and then .233 prefer. So again, we put all of the Ntp servers in here, and then let's get our time zone, clock time zone, Central European time. is going to be +2 from UTC. Remember, the default time setting is UTC. And then we've got clock, summertime, CEUT, and recurring for our daylight savings time. So let's do a write mem here and save our config. Show Ntp status. Right, we're synchronized. Everything looks good. Show Ntp Associations. And there we go. We've got our preferred system peer, and then we have our candidates below. And let's go back to router 1. And I'm wondering if the activity here, this IOU activity, is locked in. Aha! So there we go. So it is not locked in. I thought it might be locked in to only use or only function with 233. But take a look here. We've had an election, so boy, does this throw a wrench in things. It grabbed 209.165.201.111, which is almost in the middle of the remaining 4 IP addresses. So it didn't grab the highest, and it didn't grab, and you can take a look here, it even had offset, and it must be the lowest dispersion, the lowest difference is what I'm wondering here. So one last check here. Let's see if it goes with, I believe that stands for dispersion. So the difference in the time. So if I were to say show Ntp Associations, if I take down 111, it should jump, well, no, actually this one's 2.901, so that is not what happened, or it was lower here. So yeah, it was lower there. So if I take down 111, remove the statement, it should jump to 222, but that's because it has the lowest dispersion time. So let's check that out and see if that's what happens. No NTP server 209.165.201.111. So now when we say do show Ntp Associations, the lowest dispersion time should get picked up next, and that right now would be, and yeah, there it is. Take a look at that. So let's take this one step further. Let's get rid of 222. No NTP server 209.165.201, whoops, 201.222, and it should go to .44. All right, so we'll give it a second here. The lowest dispersion is 44, and let's see if that's what it picks up. At 2.923. And we were wrong. It went with 133, so that is not how it's selecting it. So I'd actually have to take a look to see, once we get past the preferred, what exactly is going on. All right, so let's put it, it looked like that was actually working for a second there, but not correct. So do show run, include NTP. So we need to say NTP server 209.165.201.233 prefer, and then we're going to come back, and which ones are we missing? We've got 111, and is it 222, and do show run include NTP. Whoops, sorry. 3, 4, 5. All right, so we've got all the servers in there for router 1 and router 2, so everything looks good. So let's take a look back here at the job aids, and that takes care of the NTP servers. Let's transition to, let's get some assistance here on the scenario. I'm trying to remember what we were doing. All right, so we've got this part of the task taken care of. You can find the NTP server information in the job section. Other network devices should synchronize their time to R1 and R2. So what we're going to be doing here is DSW1 and 2, and my guess is switch 1, are going to be synchronizing their time with router 1 and router 2. Now, one of the key things that we're going to be looking for here on router 1, let's say do show IP interface, interface brief. So we have a loopback address conveniently configured here already. Now, typically we want to use a loopback address because that's a software interface that is never going to go down unless the entire router's down. So if we had multiple ways to reach that address, we would want to use that loopback. We wouldn't want to use a physical interface because when a physical interface goes down, that interface is down. And we are not going to be able to get through or to that interface to get our time synchronized. So let's go ahead and on DSW1, 2, and switch. And actually, let's take a look here at the show IP interface brief. So 101.10 and 102.10. So this should be straightforward. So on DSW1, we'll go from user exec to privilege exec into global config, Ntp server 192.168.101.10. And it didn't actually say to prefer one or the other, so we'll prefer 10. And then we'll come back, and this is going to be 102.10. And then let's get our clock set up. So clock, time zone, CEUT is going to be +2. And then clock, and we're going to set the summertime to CEUT recurring. So that takes care of DSW1. Let's knock out DSW2. So we go from user exec to privilege exec in a global config, Ntp server 192.168.101.10 prefer, and then 102.10. All right, and then clock. And let's not do the, clock time zone. And we're going to say, what do we say? CEUT +2. And then, oops, sorry. And then we're going to go with clock, summertime, CEUT, recurring. All right. So that takes care of DSW1 and DSW2. And let's say, do show Ntp status. All right. And so you can see our stratum is at 3. Let's see, is that correct? So remember, show Ntp status. Yep, so our stratum is 2, and then these guys down the way here, because we're doing sort of a hierarchical NTP configuration, their Ntp status is going to be 3. So do show Ntp status. All right, so we're good to go there. We've got switch 1, who's the last switch. We'll get in the global config here. So Ntp server 192.168.101.10 prefer, and 102.10, and then clock time zone CEUT is +2, and then whoops, so clock and summertime CEUT is recurring. Do show Ntp status. Aha, so we're unsynchronized right now, and I'm wondering, and we should be set here. Oh, did I not put in the do show run include NTP? Let's see here. Yeah, no, we've got the 192.168.101.10 do show Ntp Associations. Whoops. Ntp Associations. All right, we've got the statements in there. It may be that it's a little down the way, so we'll give this guy some time here to sort himself out. Now, it's interesting, and Deborah had actually asked a question on this earlier in the week, and I thought it was very interesting. So there's a paragraph here that says, in a small network like the one in the example, there are no major benefits of peering DSW1 and DSW2. Check that one more time. So we'll come back to switch 1 here. So according to the document, it says there's no benefit in a small environment to peer these two these multi-layer switches here, DSW1 and DSW2. It goes on to say, let us say that you lost both of your internet connections. So if we lost that connection there and that connection there, from router 1 and router 2. It says, if in that case DSW1 synchronizes its time to R1 and DSW2 synchronizes its time to R2, their clocks can become unsynchronized. Thus, it can become difficult to compare system logs between devices. It says, if you configure DSW1 and DSW2 as peers, their time will be synchronized even in those rare occasions where both internet connections have gone down. So at the beginning, it says there's no major benefit to peer DSW1 and DSW2, and then at the end it says if you configure DSW1 and 2 as peers, their time will be synchronized in the event. So it's always a best practice to sync or to peer the devices that are located in a specific site. So to give you an example, we have a site up in Fairbanks, Alaska, and one on one of these programs that we work with, one over at NASA Goddard and another one over at down in Virginia. And they get their NTP time from the server that's located at the main facility by Washington, D.C., and we have at the local sites where we typically have either one or two routers and a single switch, is that these devices are all pairing with each other in the event that they lose their internet connection, right? Or their, I should say, their intranet connection that goes out over some T1 circuits. So again, we always peer the time locally because we want to make sure that if we have to go back and do any kind of forensic analysis for an event at that location, that even if they had lost connectivity to the NTP server, that locally their times are correct. Interestingly enough, the next step says make sure that R1 and R2 are providing synchronization services even if they lose internet connectivity. And so in order for DSW1 and DSW2 to get their time from R1 and R2, we're going to go ahead and set R1 and R2 up as masters, right? Now, just because it's not set up as a master doesn't mean that we could not synchronize our time or synchronize the time with them. So here's what we're going to do on R1 and R2. We're going to go ahead and say NTP master, and let's set our stratum to 9 on R1, and we'll say NTP master, 9. Oops, sorry, doing global config first. NTP master 9 on R2. And so now R1 and R2, if for whatever reason they both lost connectivity or either one loses connectivity, they could provide NTP services to the rest of the routers that are in the environment. So let me take a quick look back here. Even if there's no connectivity to the internet. So we've got that squared away. So Dwayne also mentions you should ensure that R1 and R2 are only going to be used for time synchronization by devices in your network. So now this is going to require us to put together some ACLs on router 1 and router 2. Let's check back here and see how switch 1's coming along. Whoops. Yeah, the associations are there, but switch 1 is not going to sync. Let me do ping, let's see, 192.168.101.10. See if we have reachability, because this could be the issue here. All right, so there's no reachability to 101.10. Do I have reachability to 102.10? So in other words, do I have reachability to either loopback address on those routers? And I do not. So let's do this. This is a layer 2 switch. So let's go ahead and say do show run. We're going to look for that IP default gateway command, which is usually toward the end of the config. So it has an IP default network, which is not the IP default gateway. And let's see. Yeah, so VLAN 1, 192.168.1.252. So the default network command is set to 254. And so let's see on DSW01, do show IP route. All right, so it looks like OSPF is running here. And we're trying to sync to 192.168.101. So there's 101.10 and 102.10. So we're picking those routes up in OSPF. Let's say do show IP interface brief. And do we have, and there it is, VLAN 1. So we should definitely have reachability from the switch. Let's see, can we ping that default gateway address? Do ping 192.168.1.254. Aha, so there we go. So we needed to ARP out. So we've got connectivity there. Let's try again now with 102.10. And still no love from 102.10. What about 101.10? No, so still not going to work. Let's see. Do show Ntp status. Whoops. Ntp status. Let's see what we've got going on here. Clock is still unsynchronized. We should have nothing going on here with the associations. So let's do this. We could refer to, let me see if I put in here, Ntp server 192.168.1.254. And actually, let's prefer that. Do show run include NTP. And we're going to say no Ntp server 192.168.1.10 or .101, sorry, 101.10 prefer. So we'll pull that out of here and let's see if it syncs up here. Do show Ntp status. Ntp status. And there we go. So interestingly enough, we could get it to synchronize. It doesn't look like we have reachability to the two distribution layer switches, although it should work. What if we say do trace 192.168.101.10? Let's see if we were to trace there, where do we get? So we'll give it a second here. All right, so it looks like it's going to time out, so we're not going anywhere. Okay, so we're going to go ahead and leave this the way it is, synced up here. And let's get back to our ACL. Now, a key thing that we remember from the lab in class is that you have to provide, let's do Control-Shift-6 there, is that you have to be sure that when you're creating your ACL, we're going to be doing this on Router 1 and Router 2, that since they are set up as NTP masters, we need to make sure that they are allowed to synchronize to the 127.127.1.1 address or 127.127.x.1, depending on what that third value is going to be. So when I say show NTP status, you can see we're set up there. What about show Ntp Associations? And there we go. And this is the entry right here. Now that we've configured ourselves, and it's interesting, it looks like on IOU anyway, and I believe we saw the same behavior on iOS, that for this local host NTP entry, that it's going to take the stratum -1. So if I'm peering to this device, or should I say, if I'm synchronizing to this device, I'm going to be NTP stratum +1. However, when this device is set up as an NTP master, this local host, it dumps the stratum down by 1. Okay, so let's get to the access list. So we're going to simply say, all right, so IP access list, and we'll call this just NTP peer. And, whoops, doesn't like that? Oh, standard, sorry. Let's drop standard in here. So IP access list standard NTP peer, and we're going to go ahead and say permit 127.127.1.1. And so there is the access list for the peering, right? Because we need to make sure that we can peer with our local clock. And then we're going to create another access group, and this is the one where we're going to only be serving up NTP time. So if I were to exit out, IP access list standard NTP _serve. And we're going to say permit, and it's very simple here. It's just going to be that 192.168.0.0, and then the wildcard mask /16, right? And then we need our NTP access group statement. So the first access group statement is for the peer, right? So we are going to be peering with the local host entry. We need to make sure we allow that in there because of that NTP master command. So we would say NTP _ peer, and then NTP access group, and this one here we're going to be doing serve only because we're only going to allow clients to synchronize to us, and our named ACL here is just NTP _ serve. I probably should have made it serve underscore only as well there. All right, so that takes care of the entry on router 1. Let's go to the entry on router 2, and let's actually check. So can DSW2, are we still good here? Show Ntp status. So we are still synchronized. And then what about a show Ntp Associations? And you can see that we are still working with router 1. So now let's come over to router 2, and we're going to do the same thing in terms of the access list. So IP access list, and it can be named or numbered. It doesn't have to be a named access list. So IP access list standard, say Ntp peer permit 127.127.1.1, and then IP access list standard Ntp underscore serve, and this is what I should have done earlier, serve only, because there is a serve. Excuse me, so we're going to say serve only, and we're going to permit basically everybody on the 192.168.0.0 to synchronize up with us, and then we'll say Ntp access group, and this is going to be the peer, right? And remember, the peer is to allow the peering to take place, and we're doing it with the local host. So if we lost our connectivity to the Ntp source that we're currently peering with, we would be dependent on this local host entry that we have, that 127.0.0, I'm sorry, 127.127.1.1, and then Ntp access group. And now who are we going to allow to synchronize their time using us? And that's going to be Ntp access group serve only. And we said Ntp underscore serve underscore only. So we'll do an in and a write mem. And it's a good thing. It's interesting. I've actually done this in production environments many times. And one of the things that you should do is I would always test. And this is a great way to test. And in fact, let's see if it does show IP access list, if it shows the hits that you're getting, right? And so this is a great way to check to see, is the ACL working? Are we getting hits on the ACL? So whenever we add in into our Ntp serve only, right, into the devices that are going to try to come to the routers to get their Ntp services, is the router showing that that's actually taking place? So show IP access list. So check the ACL that you configured to provide Ntp services only, and see if, and we actually do least permission, right? So we actually do a /32 permit statement, only referencing the loopback interface of the Ntp server. And something else that you can do is you can actually specify that the Ntp source is going to be the loopback interface. So that's also something to think about as well in your Ntp application. So again, I would always do the Ntp access group along with an ACL, and then you can quickly check to see which of the devices that you have listed here, are they hitting the Ntp server. And so actually, this kind of occurred to me after the fact. So let's do this. If I go into global config and I say no Ntp access group, and we're going to say serve only. So let's remove this, serve only. And then I say no IP access list standard Ntp underscore serve underscore only. Here, this is actually how I implement it, and I prefer it, right? I mean, you can certainly get away with that, you know, /16, but then basically you're saying, yeah, 65,000 hosts on that subnet, you know, or clients, Ntp clients on that subnet, if they want, could synchronize their time. We like to lock it down so that the only devices allowed to synchronize their time are going to actually be the devices that we know about who do need to synchronize their Ntp time. So if I was to take a look at DSW1 here, and we see the IP addresses that we've got, and then we also have some routed interfaces. So my guess is Ethernet 02 on both sides. So 192.168.99.1, but it would be, yeah, so we're going to do 192.168.99.1, and actually, you know what, there's only a single, because the switch is not able to access or synchronize yet. So, all right, so this is an interesting one. So if we had more than one device back here on that ACL, and this is what it would look like. And I guess we're doing it on a router 2, so let me look at DSW2. Show IP interface brief. Show IP interface brief. And so we're going to be 98.1. So the way to do this on router 2 would be, again, create the access list. So IP access list standard ntp underscore serve underscore only. And then say permit 192.168 dot, and let's make sure we get this right, 99.1. 99.1. And I think that is it. That's all we need in there. Yeah, so then we're going to go ahead and do up the, let's exit out here. So NTP access group, and this is going to be serve only. And it's going to be NTP underscore serve underscore only. All right. So now when I say do show NTP status, we see we're synchronized. If I say do show, router 2 is, if I say do show IP access lists, right? So we've got that access list allowing only DSW2. Now the key thing here is on DSW2, the NTP source address by default is going to be the outgoing interface of the device. And so that's why I chose that address right there, because NTP queries from this device will go out that interface to get to router 2, and therefore that would be the source IP, since we're not using a loopback address. And again, to make sure that it's working, we would say do show IP access lists, and we should see matches here if this is going to sync up. And so what we can quickly do here on DSW02, show run include NTP, to kind of force things. We're preferring, and so we're preferring 101. So let's go into global config and say no NTP server 192.168.101.10. And now let's see if we get a hit. And we should get some matches here. And we'll give it a second or two here before we wrap up. But yeah, so typically this is how we do it, is we'll do a /32 match, and match specifically on the loopback address and only the loopback address. And unfortunately we're not getting any hits here, and it's may be that it's going to take it some time, may be that it's IOU, but that definitely does work. You can see here our counters here are definitely incrementing, or they were incrementing. One last look here. Do we get lucky on no, it's not going to show us anything. All right, so anyway, so that is going to wrap up challenge activity number 10 on NTP. And so we did quite a bit here. We did the NTP server command, which is where we told router 1 and router 2 that they were going to synchronize their time with 5 sources out on the internet. We set the time zone to Central European time along with daylight savings time. And then we had all the devices in the environment, DSW1 and 2 and the switch. They set up their time to synchronize off of router 1 and router 2, and we preferred router 1, I believe. Yeah, we preferred router 1. And then we also set router 1 and 2 up as NTP masters, so that if they lost their connectivity to the internet, that they would be able to provide at a higher stratum, they would be able to provide NTP services to DSW1, 2, and switch 1. And then finally, we secured everything with some ACLs and the NTP access group command. And always a good idea, and we're still not getting any hits there, always a good idea to secure that. That way you don't end up with any unauthorized devices getting their time from the NTP servers that you've set up. All right, well, that wraps up challenge activity number 10. I will see you guys on Monday.